Well, welcome everybody to February and to the Global Splunk User Group Week. Glad everybody's able to join us. Today we are talking, if I can get the slide to advance, there we go. Splunk Connect for Syslog. This is a, okay, thanks. This is hosted by Nebraska and Iowa. It's a joint session between our two user groups. Nancy could not join us this week. She is enjoying some much needed time off. She spent some time with the family. So Splunk Connect for Syslog is something that I've recently been able to use. We had a PS engagement where we were looking to move stuff into the cloud, to Splunk Cloud. And instead of setting up a syslog-ng server, was looking at the best way to do that. And of course, the commandment is thou shalt not Splunk directly to, or syslog directly to Splunk. If you haven't seen the Tumblr page for Splunk reactions, well, there's your afternoon, because it is a rabbit hole. But with this, it's a newer technology. It's a newer option that Splunk is offering, and it is supported by Splunk. And it's really neat that it has some really cool features that let you get going right out of the box. But I'm not going to steal any thunder from Mark when he comes up. So what we're kind of looking at today, and these times are a little flexible, is welcomes, and we're going to do a little polling. What's Splunk without data? We're going to move then right into Splunk Connect for Syslog. We're going to help plan the next meeting going forward, and then go to those giveaways. So who am I? Since some of you don't know who I am Tony Ranke. I'm a network security engineer at Children's Hospital in Omaha. I've been using Splunk since 2009 and been part of the Splunk Trust for the last few years since the indoctrination of the Splunk user group, or the Splunk Trust. I run the Nebraska user group and co-run the Iowa user group with Nancy. I've used Splunk in a variety of aspects. As people have heard, I Splunk the street speeds on our street. It's a 3-block long street, but I've caught people doing 40, 45, 50 miles an hour. Saw a guy on a motorcycle actually with somebody on the back of the motorcycle doing 52 miles an hour down our street. With that, I got to know local law enforcement very well, as I can give them detailed statistics of set up your speed trap from this time, this 20-minute window facing this direction, and that's the highest probability, instead of just saying it's always speed. So they love me. What else? Yeah. So that's a little bit about me.
Did that help you get out any tickets?
No. If anything, they know that I know about speed, so they'd probably be more likely to give me a ticket.
Ah, dang.
So let's kick off the polls, just so I can get a little idea of about you, and everybody should have a poll up there. We'll give it a good 15-30 seconds here. Does everybody see the poll pop up in their Zoom window?
Yes, I see it.
All right. I'll probably have to change the share. All right, with 21 of the 25 voting, we'll go ahead and end this. Take a look at it.
I had to play with your poll a little bit, Tony.
Okay. I welcome that. So, I was kind of curious with it being a global Splunk user group and being able to attend everywhere. I was in the meeting for Cairo yesterday. I wanted to just kind of see how many people are attending, how many meetings. The majority of you are attending this one, but it does look like there's a few others that are attending others. Highly recommend going and checking others out. I was trying to stay up last night to attend the Brisbane in Australia last night, and just didn't make it. So this was one I was kind of curious. I'm happy somebody had fun with my answer, but glad that everybody's here for this syslog and not just trying to win a couple prizes. Well, I'm very happy to see that a few of you are would be interested in speaking at the user groups. Just send me a note. Definitely helps doing virtual user groups, so you're not standing in front of the room with everybody else. But I'd definitely love to help get you, into the speaking at Splunk user groups, either the Omaha, the Iowa, or more across the nation and across the globe. B-Sides is a project that I've been working on for the last couple of years with Rich Malwine and Clara. Clarification: we wanted more technical content at Conf and started a little B-Sides, help with a lot of the Splunk Trust members, and I see some other people actually even here that have given great talks. Stephen is one of them. Carrie's another. We've heard great talks about Carrie being the regex master that he is. Nobody's still on IRC. And if you're interested in Slack, I'll put it in chat in a little bit on how to join the Splunk Slack instance. It's a simple Google form you fill out, and they verify that you are a person and not a robot, and get you going. And yeah, I hate when the company blocks it. When I'm not on my personal laptop, I actually have to use the web interface for Slack to be able to get it, as they don't allow the Slack application to be installed on my work computer. Great. All right, let's switch back over. All right. So again, yes, the call for papers is open on B-Sides. Even if you don't have a fully formed idea what you could possibly be talking about, definitely throw it in there. We're looking to get the everything going, and the date that we did pick, of course, we got to do something geeky. It is May the 4th, as in Star Wars Day. Depending on how many talks that are submitted, and we have a few right now. If we need to, we will go into May 3rd to be able to make sure that we give all people that have a talk the access they need. And if you don't know why this color scheme is, it's the exact opposite of the color scheme for Splunk. It's all the inverse colors, since we are the flip side, hence the B-Sides. All right, so let's get on to our main content. Today we're joined by Mark with Splunk. He is one of the principal architects at Splunk and one of the co-authors of Splunk Connect for Syslog. Bet you didn't know he was going to be a professional volleyball player, but that career just didn't work out, and works out perfect for us, as now we get to hear him talk all about Splunk Connect for Syslog. Let me pass this over to you. Make host. And there you go. Let me stop sharing and you can share your screen.
All right. So again, my name is Mark Bonsack. Won't reread the bio, but I've been at Splunk about 10 years, mostly working as a sales engineer in large accounts, and over the years have been constantly bedeviled by the act of getting data into Splunk. So I took it upon myself with a couple of others to really try to wrangle this beast. And one of the biggest beasts is syslog and all of the attendant servers that you have to set up, all of the understanding that you have to undertake to actually do it right. Just a lot of headache that a number of us felt it should be much more turnkey. So about 3 or 4 years ago, myself and a gentleman by the name of Ryan Faircloth decided to take the bull by the horns and see if we could get a turnkey solution to this. And the result is Splunk Connect for Syslog. And I'm going to share my screen now and actually turn my video off because I have to change to a different monitor. So I'll do that and share my screen. If I can find it. All right, you folks should now see a presentation entitled Take Control of Port 514 in the primary colors. Do you guys see that?
Yes, we do. Awesome.
Again, this is a distillation, a little bit shorter version of the 45-minute session that we delivered at Comp 2019. This is a little bit shorter version because it's been out there a while, and wanted to save some time for a little bit of a live demo to show you guys how it works. And the demo is short because if it's long, that means it's complicated, and that's the one thing that we didn't want to have SC4S be. So the goal is to taking control of port 514, and Tony alluded to never send Splunk or syslog directly to Splunk, and that's what a lot of people have done in the past, is just open a TCP or UDP port 514 on a forwarder or an indexer and shove everything across the wire to port 514. So we'll explore a little bit about why that's a challenge, and why that shouldn't happen, and what we can do to make that a much easier process with a bona fide syslog server. So with that, the question and challenge that we want to address here is, as an admin, how do I easily ingest this kind of data at scale? So scalability was a huge part of what we did, and removing the requirement of understanding syslog, syslog-ng, rsyslog, all the different flavors. That was really the 2 points that we wanted to bring home, is removing the requirement of having to architect and understand what is essentially a programming language yourself, and be able to do this at scale. Prior to Splunk Connect for Syslog, this was a challenge. It was not easy, and it was something that Splunk actually pushed back and onto the customer base. So we did not have a supported solution to do this until recently. Splunk Connect for Syslog has been out there about 1.5 years now. It was released in October of 2019 and significantly worked on since. We have a continuous integration in deployment schedule. So we've probably released over 100 to 120 releases since 2019. So pretty often. So let's get into some of the challenges. And I'm going to take this kind of from at the top level, and I apologize to those who are familiar with the challenge. But for those who aren't, I wanted to certainly highlight why we built Splunk Connect for Syslog and what the challenges that we wanted to overcome were. First and foremost, what are the challenges? Well, syslog itself is a protocol and not a source type. So a lot of folks say, oh, I got syslog data that I need to ingest. Well, that's like saying I have all these cars on the freeway, and I want to, or on I-80, and I want to ingest I-80. No, you don't want to ingest I-80. You want to look at all the cars on I-80 and see what kind of cars they are, and who's driving them, and what the metadata is behind them, what colors they are. The freeway is just the highway that they travel on. Same thing with syslog. It's just a protocol. It's just a highway. We are interested in the data and the formats that ride on those protocols. And those formats are set by the vendors. The vendors get to pick what their format is, because the standard is pretty loose. There's two main standards. They're up in the upper left, the RFCs. The first one is the old Berkeley standard, which really just specifies a timestamp and a host name, and everything else can be whatever you want. And the 5424 is a little newer, has more structure, but it's not as widely used. So the fact of the matter is there's a ton of different formats. And then by virtue of the protocol itself being close to 40 years old, it presents unique scale challenges. And the biggest challenge is it's difficult, if not impossible, to load balance on ingest. And that will probably generate a lot of questions a little bit later on, but we'll get to that when we get into the architecture. So a lot of scale challenges that we've seen over the years, and they're not getting any better. There's, these new devices that are capable of handling and processing 60,000 packets per second on a firewall, they're spitting out a ton of data. So that 40-year-old protocol is being challenged, but part of the reason that they can log at that level is because the protocol is so simple, but it has its issues. So here are some of the issues that that we've lived through at Splunk for years, and the industry really has struggled with as well. And first and foremost is a lack of documentation best practices. It seems like everyone kind of goes about this on their own, and it's largely because the tools that are available have been primarily programming languages. Basically, syslog-ng and our syslog are two servers, but you have to configure them. And their configuration language is incredibly complex, incredibly flexible, and incredibly powerful, but complex nonetheless. And that means it ends up being a programming and architectural exercise. And a number of customers just don't want to do that. So they just say, screw it, I'll just send it to Splunk and see what happens. So that's a big part of it. Attendant to that is a shortage of deep syslog expertise. And again, that's familiarity with the main servers that are in wide use. And there's the two, our syslog and syslog-ng are pretty much the two that people mostly use. And so consequently, when there are challenges with getting data in Splunk, it's a support challenge because everyone does it differently. So the end result of that is, again, a lot of people punt and they just say, okay, I'm just going to send it to 514 with the source type syslog and call it a day. As we see, that will limit the usefulness of Splunk analytics, and in particular the schema on the fly or schema at read, because it makes it real hard to unwrap what's on the highway when there's no guidance as to what you're looking at. So the regex becomes really, really challenging. And then at scale, we have a very challenging issue with uneven data distribution when you use the typical forwarder arrangement with a syslog server, which we'll get to when we talk about the architecture. So those are the challenges that we've seen for years. And they're even bigger challenges because we've done our own internal metrics from a number of our customers. As Tony said, metrics are key, data is key. And we see that syslog is a huge proportion of the entire data set for many customers. So by far the two most common source types we see is win event log security and syslog. And syslog, as we've hinted to here, shouldn't even be a source type. The source type should be Palo Alto Networks threat or Juniper NetScreen. It shouldn't be syslog. Again, that's just the highway. The cars in the highway are all the devices that transfer data over syslog. So we see in this graph two problems. One is a huge amount of this data is wrapped up in this transport mechanism. And problem number two is that the source type is syslog. So we need to migrate the customer base away from this method of ingesting this kind of data. So what we, Ryan and I sought to do about 3 years ago.
Mark, hold on just a sec. I'm going to reclaim host. I think some people are still trying to get in. Are you still able to share? Yeah. Okay. Okay. If sharing's still working, I'll keep host and keep letting people in.
Yeah, I don't think I need to be host to share.
Okay.
Yeah.
Thanks.
We good?
Looks like it.
I'll actually, this is actually a good place to stop before I get into SC4S. Does this resonate with the group? I mean, and Tony, you might want to monitor or raise the hand thing if there's any questions. I'd be happy to I don't want this to be a monologue. So at this point, is this resonating?
I see the exact same thing that you're describing. Syslog dumping ground, source type syslog. We see it all over the place. I ran into a guy doing PS and he just threw up an R syslog and he's going down this route as a brand new install. And I told him to come to this. I don't know if he did, but yeah, this is totally the way to go. And it'll avoid these problems, make it easy for everybody. It's an easy button, right?
Yep.
Except there's no doubt, unlike indexed extractions equals JSON, which is an easy button fraught with all kinds of downsides. There's no downside.
Yeah. We found very little. I mean, and we'll get into the syslog being a religion. In the longer talk, we talk about, people, one of the ramifications of this is that everyone has their own idea of best practices with syslog. SC4S was intended to solve the 90% problem. 90 to 95% of the people just want to get their data in and don't want to deal with it. There's always going to be those who have, I have this bizarre forwarding mechanism and all these relays and the data's all munged and blah, 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 blah. And says, okay, you can take whatever you want. This is all open source. Take the configs and roll your own. We call it bring your own environment. But for the majority of the people, they want a turnkey solution. We settled on container. That was by far the easiest way to abstract, even obtaining the best or the most current version of syslog-ng, which is hard for a lot of people. So we built it into a container. It makes it very, very turnkey. We wanted it consistent and repeatable. And if it's consistent and repeatable, we can document it. So actually, I shouldn't say this, but 50 to 60% of the effort that we put into developing this is into the documentation so that people understand and can deploy it consistently. And that's the only way we could support it as well. And of course, it had to be scalable. So we had to re-architect the way we actually get the data in to make it much more scalable and make the data distribution across indexers that much better. So if we accomplish the 3 balls on the left and rolled those up into a package, we would have much better data hygiene going into Splunk. We'd have much more efficient operations because the data would be handed to Splunk already pre-source typed, timestamp, line breaking, all of that's already done, and handed in a nice packet or JSON blob to the HEC event endpoint, which we'll talk about that as well, the transport mechanism. So much more efficient on the indexers and on Splunk in general, much easier on the author of the TA as well. And if you get that, you get a much higher customer satisfaction and you get much quicker time to value. It's an easy button. It's fast, it's easy, and it just works. That's what our goals were. So in reality, we wanted to take the connection or the ingest of data from a raw event that you see here. This happens to be a Juniper event in its raw form on the wire. And we wanted to simply deposit it to Splunk looking like this. So all the blue is a metadata that is proper on ingest. There is no TA, no Juniper TA has been installed on the Splunk system that has this event. So the host is properly extracted, the source is proper, and where it came from, and also the source, most importantly, the source type. So if you're an author of the Juniper TA, it would be much easier to see and have a source type that's already predefined, knowing it's a Juniper, rather than having to unwrap, hey, is this Cisco message me? Is this Palo Alto message me? And having to toss those over the transom until you get to a bona fide Juniper event. And the other TAs have the same thing. So the TAs do a lot less work figuring out what they own when it's already pre-source type. So that's what we want to do. And if it if the opportunity presents itself and they're using the structured format of syslog, which this event happens to be, you can even display it in full JSON if you want. So you don't have to do even less work to actually search these fields. They're directly searchable without a TA. It just lands. It lands in Splunk looking like this if you want. That's all configurable. So that's the goal, is to really be able to take the input to the output without having to do a whole lot of work to make that happen. So here is where we're going to spend a little bit of time. And I'll explain the architecture and then I'll open it up for questions, because this is where you're going to see a lot of questions, perhaps a lot of pushback, and it all goes back to the protocol being so old. So on the left is an architecture that you're probably familiar with. So network devices are in the lower left. They go through a load balancer to 1, 2, or 3 or 4 syslog servers. They have a universal forwarder on them, and they send their data to the indexers. That heck is wrong. It's sent over S2S, or the Splunk to Splunk protocol. So it uses the universal forwarder auto LB. The problem that we saw, and one of the early reasons that we did SC4S, is that at scale, what happens is the number of indexers can be 50 to 100 at very large scale, but the data from the network devices is aggregated to just a few syslog servers. And the problem is, whenever you have a single forwarder that is aggregating data and then trying to fan that back out into a lot of indexers, the way the time slicing works on the protocol is that you have a specific set of time, and it defaults to 30 seconds, where one indexer is going to be sucking all the data and the other 99 of them aren't. So if you have a search, a short-term search for that same data in a short time range, and enterprise security does this all the time with DMA searches, you're going to have only a couple indexers participating in the search. So data distribution becomes a challenge when you have aggregated data. The forwarders work great when you have 10,000 of them out in the fleet, and each of them is only providing a very small amount of data in proportion to the whole. But syslog in this setup, as noted, this could be 50% of the entire ingest for the whole architecture. And this is where that protocol breaks down. So we had an early scale issue that we sought to address first. And that resulted in the architecture in the middle, where we have Splunk Connect for Syslog that replaces the syslog-ng server and the universal forwarder on a single box, and replaces it with a containerized version of syslog-ng. So the nice thing is we're not ditching syslog-ng. It is a good product, one of the best open source products I know of. And I have an open Slack channel with the author of syslog-ng that can fix core dumps for me in 24 hours and get them out the door. So really solid piece of software. We decided to stick with it in the container, but we decided to abstract it so that you, as the consultants, the customers, the users, don't have to understand how it works unless you have a very specific case, in which case you can use the full power of syslog-ng even with the container. So we don't lock you out, but we make it a whole heck of a lot easier. And then the other big architectural change you'll see here is that the load balancer on the front side is gone. And the reason for that is because the protocol itself at the application level, layer 7, is unacknowledged. It's a send and forget protocol, even with TCP. It's a single message per packet. It gets sent. There's no acknowledgement of whether or not that packet got delivered to its final destination. And that's by design. It's because, yeah. Go ahead.
I think it was an inadvertent mic.
Okay. All right, I'll stop for questions here in just a second. So And basically, you know, getting back to the load balancer itself, in an attempt to provide one of two things, either scale or high availability, fails in both because the load balancer technology, F5, Nginx, pick your poison, is 20 years after the fact of the syslog protocol itself. So normal buffering operations in a load balancer will actually cause more packet loss than if you just use like a keep alive D in an OS clustering situation for high av. And even better yet, syslog is edge data collection. So the goal is to get, not to try to scale vertically and say, you know, build a syslog-ng server that can handle 10 terabytes a day, but deploy 10 of them that handle 1 terabyte a day, but get that red box out to the edge. And it turns out my colleague or my co-author, Ryan, wrote a blog in his experience in major installations. He's been a PS guy and a PM guy at Splunk for years. And he has ripped out more installations of syslog with front side load balancers because they end up dropping more data than if you just fan the collectors out to the edge, get them out to the management planes, and actually use UDP because it's more efficient for the device without any intermediate network infrastructure between the collectors. So you deploy a bunch of the red collectors to the edge, and instead of depositing the data to disk, in memory, transfers it to a protocol that is load balanceable and should be balanced appropriately, and that's HTTP. And it's tailor-made for Splunk Cloud because that HTTP load balancer you see in the middle, that's the HEC endpoint in cloud. So SC4S is tailor-made for Splunk Cloud because you don't have to deploy any of the infrastructure to get the data in. It's already done for you. And the red box is just a turnkey container that you deploy, even as simple as a vMotion, VMware guest machine, guest running Red Hat makes a great SC4S host. And then in the future, there's going to be pub sub buses. Kafka's shown here. Splunk DSP is another sync that we'll be able to send to, and other routing decisions can be made, by virtue of it being in a pub sub setup. But all of this is possible, and even the Kafka can be done. And DSP is now. That future, this was done a year and a half ago. That future can happen now if you want. But the main 99% of the deployments happen in the middle, where we have customers writing directly to the HEC endpoint in cloud or on-prem. On-prem, it would be to the indexers as shown. And that's the way cloud works too. So I'm going to stop now and open it up for questions before we go on.
So I have a quick question. So hypothetically, if we just signed the contract for Splunk Cloud, as part of that migration and redoing our forwarding tier and stuff like that, would you recommend that we would take a look at doing the Splunk Connect for Syslog instead of what we're doing today?
If you're using the architecture on the left, 100%.
Yeah, that's what we're using. Okay.
You should migrate as soon as you can.
Cool. Thank you.
Yeah.
Craig, that is exactly what I just signed for cloud, and that's exactly how we did it.
Are you? Perfect. I might reach out to you and
Yeah.
on the side and see how that's going.
Yeah.
Yeah, and it's not to say that it's in the documentation we outline. If you do throw some heavy metal at this, and I have a customer that's doing clustered pairs of 48 core, 196 gig boxes, and they're getting north of 6 to 7 terabytes a day, and they've even stressed it, of data through a single red box. So it will scale vertically really, really well. But usually the first question I ask when a customer comes to me and say, hey, can I put 5 terabytes through this? I'm going to say, how many data centers is that? And where is this collection point in the architecture? Because if it's central, you really want to get it to the edge. And that has nothing to do with scale, but everything to do with the protocol and its inability to traverse network infrastructure. It just sucks at it. It's just, you got to get it out of the syslog protocol as soon as you can. And once you do that, you'll be much happier. So.
Question on, so we do some of our existing stuff. We do have some log sources that get re-forwarded off from syslog to another syslog. Is that something that's capable with the existing design, or is that an output that's not easily accessible?
So you want to send, you want to receive events that have been relayed, or you want to relay events?
Relay events with based on a filter.
Yeah, you can. SC4S provides for alternate destinations,
Okay. And
it provides a way to filter what gets sent to the alternate destinations.
Okay. That's good. Yeah, because the example we use, if so we have like logon events that come from our VPNs or come in from our wireless network, and we forward them to our Palo Alto tier for user identification, so we can do user ID mapping at the firewall level. So we just basically say, well, our syslog gets it, rather than having somewhere else resend it. Like, just send it from the start source to the end source, and so that way it's a little bit of a man in the middle, but at least it's only parsing the syslog events that are most important and forwarding those off, rather than shotgunning all of the data to another syslog's receiver.
Yeah. Now, I mean, it's an aside, but I'm wondering if you send the ones that you're requesting user authentication from Palos, and that Palo itself logs, you might have a double log situation. So
yeah, no, we're not doing that. We have like wireless authentication traffic. We have VPN traffic. Those things are getting sent. Those syslog events are getting sent to our Palo Alto tier. The Palo Alto logs themselves, because once again, it's a filtered specific thing. Yeah, they don't get, there's not reciprocal.
Okay. Yeah, that's just a side.
Yep.
Yeah, lots of ways you can skin the cat. I mean, you can elect to send the filtered alternates to just Palo Alto and not Splunk, and then Palo processes them, and their logs go to SC4S as part of a Palo Alto feed, and that's where I was going with that. So there's a lot of ways to skin that cat. So it makes, and the thing that's nice is the way that, and I haven't gotten into in the following here, which I'll move on at this point if there's no more questions at the high level architecture as to how the container is built, because that'll shed some light on how you can do some of this stuff. So the way that we've architected that, the red box, so now we'll talk about the red box a little bit, is that it's very, very simple. We've built in a syslog-ng server that has been configured specifically for transport over HEC to Splunk. So we've made that completely abstracted. We've also included a disk buffer, because there's the very real case that your edge collectors will be separated from the mothership. So you don't want to drop data. So we have the ability to buffer to disk. That's all transparent, happens in the container. And when the connection is restored, the buffer empties. So it's a FIFO buffer. You do want to have fast disk there, because it is a FIFO buffer. The way syslog-ng works is that it has to empty the disk buffer before it goes back to an in-memory conversion. So definitely want to have fast disks there, but it doesn't have to be a lot of disk. It's your risk tolerance and how long you think the outage will be. And then the universal base image from Red Hat is what we base it on. And that's in a container. And you can run that out of any container runtime you want. Docker, Podman are the most common. And we're also supporting micro Kubernetes as well. So, and that's actually a way to get quote high-av from SC4S as well. So that's that. The other thing that we do is, and a big part of the functionality is understanding the incoming traffic. So the one thing that we say you can't do is send 514 traffic directly to Splunk, but you can send it, and should send it to SC4S, because SC4S is able to unravel the payload based on the filters that we write internally, So identify it, parse it properly, and that parsing might include a timestamp that's in the payload and not in the header. That happens all the time. And then format it appropriately for the, and 99% of the time we format it for what the TA expects, because we built SC4S, but a lot of the TAs haven't been redone. And so we have to make sure that the output is consistent with what the TA wants to see. So that kind of guides us in what the format is. The format can be JSON, like you saw, or it can be just inline linear, which is what most TAs expect. But the key thing also is that the source type is set properly. So out back end comes Cisco:\ASA as the source type. And right now we have probably about 40 to 50, and that's not even counting classes like Ceph and Leaf, which have a number of vendors that use that format. But we have probably about 40 to 50 different sources that we understand. And it's all the big names in network and security devices that you see out there that use this format. They use the syslog format. The one thing that we see a lot of, or some of, I should say, is people trying to use syslog for general purpose OS logging. And for that, we still recommend a universal forwarder. So if you're going to be sending Linux logs, we would highly recommend a UF over syslog, even though we can parse it and deal with it. But for almost all logs, we should, or all general purpose logs, we should be using the UF. So that's kind of how the filtering works. And here again, I alluded to this earlier, is solving a 90% problem. And the reason that we chose this approach is that in our experience, and you guys have probably seen this too, is that syslog is a religion. It's everyone often way over engineers it. It is a lossy protocol. I liken it to MP3 versus CD quality. You're never going to get true high av. So trying to design for it ends up being, generating some Rube Goldberg installations that really don't, at the end of the day, at the end of a year, how many packets have you lost? You're generally worse off. It won't solve 100% of the problem for 100% of the use cases, but we provide all the configs on an open source basis for those who need to adapt. So you can see here, I won't read these, primary goal is 5.14. Simple customizations, like I have Juniper sending on 15.14. Yeah, we can do that. So unique ports and host names. Goal again is little or no configuration experience for syslog-ng. Has to be easy to deploy. Like in air gap environments, we needed to have that solved for public sector and DoD and all of that. And we needed it to be turnkey. So that's kind of how we decided how to go about designing this thing. So again, it ships with predefined filters. For most of them, you can send a 5.14. For some of them, you have to provide a unique port or a host name block because the data is not unique enough. There's only a few that fit into that bucket, but there are a few, like Aruba access points. They're just so vague. And it could be from anything that there's no real way to discern it from a Juniper or anything else. So just a few that you need to provide a port for. Other than that, you provide a URL, a HEC URL and token, and a default collection port, which is defaulted to 5.14, how big you want your disk buffer, and set those as environment variables that's documented as a in the setup directory, and off you go. And Tony, I don't know if you want to describe your experience with that and what you went through, or anyone on the call that's actually tried SC4S. I'd love to hear, real customer testimonial as to what you guys did to get it going. That'd be great.
For us, I'm still pretty new at my company, so a lot of it was working with the different network teams to ensure their products, because I made the mistake of saying, hey, Cisco devices need to go to this port. I think it was for example, 5515 is going to be Cisco. Well, that became an issue because we have call manager, we have the Cisco floor switches, ASAs. Our network team loves their Cisco, so there was just so much Cisco coming in that it was kind of getting confused on what to do. Again, 90% of all the data, perfect. It auto identified it, but once we went to the call manager going to its own port, ASA is going to their own port, just made it so much easier. But yeah, the only thing that we struggled with was at the beginning doing a custom source type to some of the products that weren't in SC4S yet. Once we figured out that pattern of how to do a custom source type or a custom product, then I've been able to just get going and get data in.
Awesome. Thanks for that, Tony. And you bring up a good point. There's a blog series that, and I will get Tony this this data because I don't think it's in this deck. But I recently added to the blog series that outline, what we've been talking about now, as well as how to expand it for data sources that aren't out of the box. So a whole authoring guide on that. And if you, let me see, when I stop sharing and go to the demo, I will pull up the blog series and put the blog in the chat window so you guys have that, because it's hugely valuable if you want to add a data source. So don't let me forget to, because you know what? This is it. That blog, that is valid. So let me do this.
On that Slack channel is very active and very responsive.
Okay, so I need to reshare. So hang on a second. Before I do that, I'm gonna put all of this in the Slack. I mean, in the Zoom chat. Hang on. And hopefully it cut and paste okay. Yeah, there you go. So it's in the Zoom chat. That blog series is a 4-part series. So the parts 3 and 4 were released in December, and it shows the deep level configurations beyond the basics, because there are definitely unique ports, and there's other things you can configure. You can configure TLS, all sorts of compression, all sorts of certificates, all in both inbound and outbound, lots of stuff you can configure. And that's all in there. So with that, let me organize a quick demo here. Because I know we're running up on time. So let me just share this real quick.
And I did the roll your own since we didn't have Kubernetes, or a real good way to use the Docker or Kubes. So I did use roll your own, and their documentation and their step through worked really well for being able to get it going.
Yeah. So again, if you can't use a container for whatever reason, although I highly recommend the container, it's so easy. And only if you can't, I mean, there's a number of organizations that sometimes hiccup on getting Podman or Docker, but if you can use the container, your life will be easier. So that's just what I've seen in real life in the field. So Tony, can you let me share again? It's not letting me share.
Yep, just a sec. Let me coast. Give it a shot now.
All right. That's not what I wanted to do. Share screen. Okay. Can you see my Splunk and my terminal? I'll get this out of the way.
Yes.
Okay. so you guys can see that. Okay, so real quick, on the right-hand side, I'm simulating a Palo Alto threat event, I have a little test script. And this is getting into the weeds, so I apologize, but sometimes you just have to test stuff on the wire. So the script, all it does is echo a raw syslog message to port 514. That's all it's doing. So when I run these little scripts. So now when I run, let's do Meraki, for instance. So if I run a script called the Meraki event, so you can see the raw event on the right, and then you can see the input into Splunk on the left. And the key thing is that the host name is pulled out correctly. The timestamp is correct. That's all handled automatically. And the source is set right. And most importantly, the source type. So now a couple of things you'll note here. You can see here in the raw event, here's the header. So 134.1, here's the host. And then the payload starts just to the right of the blue, starting with security event. So you can see about a quarter of this event, if we were going to suck this straight into Splunk, you would be spending about 25% more on Splunk license because you're ingesting data that you don't need. You don't need to have the timestamp. It's that big long epic timestamp, the host. That's all metadata. So that's reflected in the timestamp. It's reflected in the test CM Cisco Meraki host is all reflected properly, and then it's source typed correctly. So the event that gets ingested into Splunk, in which the TA can start with, starts with the security event, the actual payload. And at that point, Splunk can take over, the schema on the fly and all that can do the same thing. The same ideas. So here, test iOS, any of these flavors, some of them are real short. So here's Cisco iOS. And again, it starts with the mnemonic for Cisco. So it starts way over here. All of this header stuff in blue is not ingested because we don't need to. So you can see here the 1859-48-411, there's the time, and the actual indexed event starts with the mnemonic, and off you go. And again, you have the proper source type. So all of this is out of the box. So you point all of these events at 514 and the right thing happens, which at the end of the day is what you want. So the demo's short and sweet. That's what the events are supposed to look like. And that's the goal. So when you start pointing all your devices at 514, you want it to look like you see in Splunk on the left, so that the relevant TA has an event that they know looks like a Cisco iOS event, and they don't have to filter through that Meraki event, which looks totally different, and the Palo Alto threat event that you saw below, which I had done prior. The pan threat event is yet again a completely different format. That's really the goal. And the other thing that's kind of cool is that in these events, there's a bunch of indexed fields that come along for the ride. So that sequence number that you saw in the Cisco event, that 30, there might be an administrator that wants to see that sequence number. So that's in there. The container name, so you can determine what syslog server sent the data, and also what port it came over. So all of this metadata we bundle into, and then facility and severity, which is in that 190, that's the PRI block in syslog. People might want to filter on syslog, facility, and severity. And then we enumerate the vendor product with a vendor underbar product nomenclature. So these indexed fields come with any event. So you can see here that the Palo Alto ones are completely different. So, it's the protocol 514, same thing. The vendor product in this case is pan threat. So those are just some of the things that come with it as well. And these indexed fields can be either sent or not, depending on, because some people say, I don't want the overhead of that. Well, you can turn that off, but it can be very, very useful for people. Particularly things like, hey, where did it come from? From host IP. What was the IP of the sender? You know, independent of what was in the message. That can be very, very useful. So that's part of the part of SC4S as well, out of the box. All right, so we're at the top of the hour. I know that's where you wanted to stop, Tony. So any last minute questions?
Yeah, Mark, thanks for presenting today. And also thanks as always to Tony for keeping this alive and going. But how would you handle filtering unwanted data? Would that be in the config of the container itself, or what would be the approach? And I'm thinking more like how you null queue on a heavy forwarder.
How you what now? Excuse me?
How you would filter unwanted data on a heavy forwarder, for example, we would just write a regex to send unwanted data to a null queue. How would that be?
Yeah, so there's a destination. We do have a null queue destination in SC4S, and that is an alternate destination. So I didn't get into the details of this, but filtered alternates is a environment variable you can set. And when you provide the equivalent regex, and that's likely what it'll be, in a syslog-ng filter, because one of the things that I didn't describe, and this gets into like part 3 and part 4 of the blog, but I'll show you guys this. Here, in fact, it's up on the screen. Here is the environment file, and it typically lives in opt-SC4S on the server. And here's where you put the token. Here's where you do TLS and all of this. And then here's how you listen for unique ports. But here, down here, here is where you can specify for Palo Alto, in this case, filtered alternates. And these are the alternate destinations, and they're bona fide syslog-ng destinations. And you can build your own destinations as well as use the internal ones, such as HEC. But then there's also a environment variable above it that says, well, what is the filter? And that is the alternate destination filter. And that's a regex saying, if I'm getting Palo Alto PAN-OS and this filter matches, I want to send to these alternate destinations.
Gotcha. And
if you send it to the null queue and only the null queue, you'll drop the data. You'll just filter it. It's gone. So that's how you do it.
Thank you.
So again, it's almost all environment variable driven. And then there is a stub of the a couple things that I'll point out and real quick in the local directory, which is mounted to the container. So the container sees this. One of the directories it sees is a context directory. And one of the key files in here is Splunk metadata. This is basically a list of the vendor product pairs, such as Cisco Meraki that you saw earlier. If the vendor product is Cisco Meraki, which this one is on the left, I want to send it to the net FW index. Well, one of the most common things customers want to override or need to override is where the data goes. So we provide a way for all of the supported sources to be sent to alternate indexes, you know, and alternate other metadata. So you can change the host and source type too. And that happens a lot for like leaf data. So if you have, you know, leaf data coming over leaf, or the protocol is pretty benign, you can change the source type here. So a number of different ways. CyberArk is a better one. That's a leaf source. So, or a Ceph source. So whenever we see CyberArk Vault as a Ceph entry, we're going to set the source type to CyberArk EPV Ceph. So that's an example of overriding metadata. The other thing you want to override and gets commented is, or common is overriding specific events that might come from specific source types with CS, overriding specific events that come in on a specific
Actually, I think he might have had a conflict. I think he pinged me already. Let me double check, but I believe so.
Hello?
I think there was an accidental.
Yeah. So here's where you say, hey, I want to set or check a filter, and I want to change the Splunk host to firewall 01 based on a filter. And if you look at the comp filters, here is where you can say a filter, I want to match the host to firewall 01 or the net mask to 192, or you can put in any regex for the message you want in here too. So that's how you override data. That's how you do that null queue thing I was talking about. Is you actually provide a filter, and these filters are bona fide. This is the only part of syslog-ng syntax you need to know, because this directory is actually mounted to the container and referenced there. So also in config, you can configure, actually I don't have anything here. You can configure alternate destinations as well, and filters for custom source types that you might develop. So lots of choices for expanding the environment, and that's outlined in part 4 of the blog. So I think at this point we truly are out of time, and
Oh, no worries. If people want to talk, I'll let them. Yeah, because we can do the planning the next meeting via Slack and email or the forums, because now there's the user group forums that we can use to continue the conversation. So if there's any more questions, let's go ahead and ask them. Well, we still got a few minutes left.
I'd just like to say that I used Mark's syslog to hex stuff back in 2017, and this is much more refined and much better. And I like the stuff back in 2017. So I will definitely say this is the way to go for syslog to Splunk.
well, thanks, Gary.
All right, hearing none, we'll go ahead and thank you, Mark. This was a great talk. Got a lot of comments on the side, so this was very well done. If there's interest in going deeper, maybe we can schedule something later, a follow-up meeting to this meeting. All right, get back to seeing my face here. So we're going to go ahead and conclude this. There'll be a follow-up email for everybody to this meeting with the links that Mark provided. Also for ideas, and you're getting your thoughts on upcoming meetings on what topics we want to hear. And if you have a use case for Splunk, love to have you present and give nothing else, 10-15 minutes on how you're using Splunk, because how you're using Splunk could be different than how everybody else is using Splunk, and they may get some ideas on how you're doing it. We'll go ahead and in there. If you want, I'll keep the Zoom open for another 5-10 minutes if you want to chat among yourselves. Thanks, everybody. Thanks, Mark.
You're more than welcome. Take care, all.